In this tutorial, I'm going to show you how to create a chatbot, and we're going to be doing it using OpenAI, Django, and React. The chatbot that we're going to create is going to be a very simple one. It's going to have a very basic interface that allows you to type a message like hello. It'll send the request to the OpenAI backend API, and then it will return a response. So you can keep asking it questions like what should I eat for lunch? And you can interact with the chatbot in the web interface here. So it's very simple, but I'm going to be showing you all of the concepts that you need in order to integrate AI into your application using the OpenAI API. So we'll start by doing a design overview. We'll plan out how we're going to implement our application and what the architecture is going to look like. Then we're going to be creating our database models that are used to store the chat history and the chat session. We're going to configure OpenAI to have an API key that we can add to our project so we have access to the OpenAI APIs. Then we're going to handle some AI requests. So that is the request that we send to OpenAI and how we handle the response. We'll also handle the chat prompts that the user enters into the chat. And we'll create a chat API on our backend that allows our front end to make requests and receive responses. And we'll create the chat page that I just showed you in the React front end that we have for our project. And then once we have the chat page, we'll integrate it with our chat API to have a working chatbot. So the prerequisites for this tutorial are the starting source code, which I will provide. That's a project that includes all the basic components that you're going to need, such as React, Django, a database, and it's all set up using Docker Compose. We created all this code in the previous tutorials in this series. So if you want to go and learn how we set this project up and how we created a project with Docker, Django, React, and so on, then you can find all of those videos in the links in the description or on our YouTube channel. So the other thing that you're going to need other than the starting code is Docker and Docker Compose. That's really the only dependency you'll need on your machine because that's what we're going to be using in order to run the code. You'll also need an account on the OpenAI platform. So that's different from your standard ChatGPT account. I'll put a link in the description to show you how you get there, but essentially it's what you need in order to be able to interact with the OpenAI APIs. So basically you set up an account and it charges you based on usage. So you will need to provide some billing information for that. Also, if you like this content, then please support our channel by liking, subscribing, commenting, and sharing the videos. It's much appreciated. And also visit londonappdeveloper.com for more courses and tutorials in programming. Now let's go over the design of the application that we're going to build. So we're going to be integrating with OpenAI, as I've said before, and we're going to be using specifically the chat completions API because that's the best API for performing chat operations in OpenAI. We're then going to store the context of all of the chat history, so that's the messages we send and receive in the database. And we're going to be using async tasks to call the completions API. And that's because these requests to the backend API can take some time. So we're going to use async tasks so it doesn't block the user interface. We're also going to be using polling from the front end. So that's when the front end makes multiple requests to the backend in order to get the messages. Now there are better ways to do this, such as WebSockets and so on, but we're not going to be covering that in this tutorial because it just adds a lot of extra complexity. I'm pretty confident that if you learn how to do it in this approach, then you could build on top of it and you could add WebSockets at a later date if you wanted to. So how does the chat completions API from OpenAI work? Basically, it works by sending a request, and in that request, you include the model that you want to use, and the model influences how much you're charged for the request. And I'll be showing you some of the different models and the pricing a bit later. And you also include any messages. So that's the kind of minimum information that you need to include. There are other things that you can include if you want to customize the request and things like that. However, these are the bare minimum requirements for a request. Then you, of course, receive a response after a few seconds. It gives you a response, and that response includes a message, which is the AI's response to the messages that you sent. The one thing that you need to keep in mind is that you need to keep track of the full history. So that's every message that is sent and received to and from the AI model. And that's because this is how the APIs work for OpenAI and most of the AI providers that are out there. So yeah, as I said, you need to keep track of the context. So the context that we're referring to here is the history of the chat. So that's all of the messages that have been sent and received. So let's take a look at an initial request that you might send to OpenAI. I'm going to show this in JSON here. So this is the JSON example. We're going to be doing it using the Python library. However, essentially this is the information that is sent in the request. So we start with the model on line 2, and that specifies which model we want to use. We're using the GPT-4o mini model, which is a cheap model that we can use for testing. So it's not super powerful, although generally it's pretty good for what you need to do, especially what we need to do here. So basically, you specify the model that you want to use, and there's a whole list of different models that you can choose from on the OpenAI website. Then you list the messages, and each message has a role and some content. So the roles that are available typically are system and user. They're the main ones that we'll be using. You can also have other roles like assistant and so on. However, we're just going to keep it simple and just stick with system and user here. The assistant role will come in later as we get responses from the API. So essentially the system role is used to set up how you want your AI chatbot to behave. So this is where you would pass in any context or any information that you want the AI chatbot to have when users are interacting with it. So this is really where you can customize and tailor the chatbot to behave as you want it to behave and pass in any information that might be relevant for users to interact with. So in this case, we're telling it, you are an assistant who's had too much coffee. So we just kind of, as a bit of a funny chatbot, we want it to respond as if it's had too much coffee. And we'll see how that responds. And typically the actual user of the system, so the person that's using your chatbot, won't see these messages. The system messages are sent behind the scenes to set up the chatbot and tell it how you want the AI to interact with your user. So we pass in the system prompt here, the first message, and then we pass in the second message, which is with the role user, how are you? So this is something that the user actually typed in and sent. So we're saying, how are you? And then we're going to send that to the AI API and we'll see what it responds with. Okay, so a typical response would look like this. Again, this is a bit more complicated because it contains all the information about the metadata about the request and so on. But really, the main thing that we care about in this response are lines 20 to 22. So this is the messages response that's sent, and this is the actual response that came from the AI chatbot. So you can see here it says message on line 20, it's got the message object, and then on line 21 you've got the role assistant. So this is saying the chatbot assistant, which is the AI chatbot, responded with the content buzzing with energy, you. So that's the kind of chat flow that we've had so far. The next request, so when the user responds to that message, will include the full history of messages in that new request. So we'll keep all of the messages there and we'll just add the latest message that was sent. And this gives the AI chatbot or the AI model the context and all the information of the chat history that's happened so far so that it can keep all of that in mind when it's responding to your request. So that's essentially how it works. Let's quickly go over some of the costs. So costs are based on tokens. Tokens are essentially the size of the input and the output from the chatbot. So generally the rule is that you have 4 characters per token. So every 1 token allows you to send 4 characters essentially. So we're using the GPT-4o mini, which is the 4th one on the list. It charges you for the input 15 cents per 1 million tokens. So in order to be charged 15 cents, you would have to put in approximately 4 million characters. And then you also charge differently for the response. So for the output, it charges you 60 cents for 1 million tokens. So essentially what that means is you can get 4 million characters back from the AI chatbot, and then you'll be charged 60 cents for that. When I was experimenting with this and I sent quite a few prompts back and forth while I was testing it, I was charged less than 0.1 cents. So I would be surprised if you're just using it in the same way I am, you'll probably be charged less than $1 or so for the request that you make. So now let's go over the components of our application. So the application that we have is a Django application that has a React front end and a Postgres database, and it uses Celery for the background tasks. Now, all of this is already set up in the example project. As I said, that we do have tutorials on how you set this up. So if you're interested in learning all of that, then there are videos available on this channel that will show you how to do that. So the main thing we're going to be focusing on is building on top of this architecture that we already have in order to create a chatbot that allows us to interact with OpenAI. So we'll be adding OpenAI integration, we'll be adding some models and so on in order to interact with it. Okay, so let's take a look at the database structure we're going to be setting up. This is a very simple ERD, entity relationship diagram of the database. It's a simple database. We're not doing anything too complicated here. So we're going to have an AI chat session, which is going to keep track of the current session that the user's interacting with. And then we're going to have an AI request, which is going to keep track of the requests that are sent to the AI chatbot, and it will be used to store the responses that we receive. So let's look at how the session management is going to work. So it's going to look a bit like this. We're going to have the chat API, which we'll build into our backend, and that's going to send messages to our session object, which is a model that we're going to be creating. That session is going to keep track of all the messages and all of the responses by creating and interacting with AI request objects that are linked to the session. So you create a session, every message that is sent to the AI API is going to be sent as a new AI request. And we can then keep track of all the history of messages by looking at all of the AI requests that were sent in that session. And of course, I'm going to show you how we set all of this up in our models as we go through. Okay, so that's an overview of everything we'll be doing. Now let's dive right in and start creating our project. Okay, so let's go ahead and start creating our project. So as I said, we're going to be starting using the sample code, which I linked to in the resources of this video or the description of this video. So go ahead, open that on GitHub and clone that to your local machine. So I'm going to open up my terminal here, and this is the location I want to store it. So I'm going to type git clone, and I'm going to call this the chatbot. Okay, so then open up the chatbot project, and let's just go ahead and start the existing server just so you can see how the existing application is set up. So I'll open it in the code editor, and then I'll type docker compose up watch. So this is going to build the application and start it. It might take a bit longer for you if it needs to pull down the images and compile them on your machine. But essentially, I've started the project here. So if you go ahead and open up the browser and go to localhost, we got the front end running on localhost 5173. And this was just a sample React project that we added to our application to test the API. So this essentially sends a request to the backend and returns a response. If you did the previous tutorials, then you'll already know that. And the other thing that we have is the Django admin. So if you go to localhost :8000/admin, it takes you to the Django admin page. So one thing that we can do is create what we call a super user. So if you didn't follow the previous tutorials and you don't have that already set up, then we'll do that now by just running docker compose or run --rm app backend, and then Python manage.py create super user. And you hit enter there. I'm going to give my name Mark as the username, and then we can just put mark@example.com, and then I'll put in my password. And this will create a super user in our local database that we can log in with in order to test our Django admin. And this is going to be useful for when we're creating the models and we want to test them by creating objects in the models in the admin interface. Okay, so once the project is cloned and set up, we can go ahead and start creating our database models that we're going to use to track sessions. Okay, so if you just minimize the browser and go over to your code editor here, I'm using Visual Studio Code. You can see here in the project, we have the layout of the Docker Compose configuration, which is used to define the services that are used to run the service on our local machine. And we have the Docker files for our backend and for our front end. And we also have our front end code in a directory called front end. And that's a React project, as I've said before. And we have the backend code in a directory called backend. So what we'll be doing first is creating some models in our database. So in order to do that, we're going to open up backend core models. This is where we're going to store the models. We can ignore the recipe model that's already there for now. This is going to be used a bit later. And if you want to get rid of these squiggly lines here for the code editor, then we need to create a local Python virtual environment that we can use, because all of our stuff is wrapped up in Docker, and Visual Studio Code doesn't have access into the Docker container in order to access the Python runtime. So we can do that by just typing python env env and then source env/bin/activate and then pip install -r requirements.txt. So this will install our requirements, and then we click on yes here. It should allow us to have IntelliSense and things like that inside the editor. I'll just close the editor and open it up again, check that it works. Okay, yeah, so it seemed to go away, the warnings here. Okay, so now that we have that set up, we'll go ahead and create our model. So we'll be creating two models. One is called the AI chat session, and that's going to be a simple model that's just used to keep track of the current chat session and all of the requests that are made to the AI API. And then the other one is going to be called AI request, which is going to contain all the information about the AI request, and it's going to be used to store the response from the request that's made. So let's create a class here underneath the existing recipe one called AI chat session, and we're going to base it off models.model, and we'll add a comment here that says tracks an AI chat session, and we'll just add two fields here. So it'll be created at equals models.date time field auto now add equals true, and updated at equals models.date time field auto now equals true. Okay, so that's just a simple model that it will have an ID by default, because all Django models have a primary key ID, so we don't need to add that. The only things we're going to need are the ID, the created at timestamp, and the updated at, and we don't even really need these. These are just to have something in the model if you wanted to look back and see when the chat sessions were created. Next, what we're going to do is create our AI request class. So we'll do class AI request, again from models.model. We'll add in the description here, represents an AI request. And then we're going to add a status. So we're going to have some status options. We're going to use different choices on a standard char field. So I'll show you how we do that. But first, let's create the different states that a request might have. So the first one is pending, and that will just be a string pending. And then running equals running, and complete equals complete, and failed equals failed. Okay, so these are the different states that a request to OpenAI may have. It's either pending, as in it hasn't been started yet, running, in that it's currently being processed, complete, in that it's been complete and successfully returned, or failed, something went wrong, the AI didn't respond as we expected, and the request failed. So these are the different statuses an AI request can have at any given time. The reason why we're going to add this is because essentially, we're going to be using asynchronous tasks in the background to run these requests. So we need to be able to track the status of the request so that we know what to do with it next, whether that's to run it or to show it in the chat session and so on. So that's why we need to keep track of these request statuses. Now we just need to bring all of these together by doing status underscore options equals, and this is a tuple, so it's very important that all of the commas and everything are accurate here, because this is going to provide the list of options and the human readable version of that option for the user in the Django admin interface. Not super important, but it's useful to have. So the first one, again, pending, comma, and then pending. Again, it's very straightforward here. The second one, running, and we'll just call that running. Second one is complete, and we'll say complete. And the last one is failed, we'll say failed. Okay, so now we can add a status field. So we'll do that by typing status equals models.char field, and then choices equals status underscore options. and default equals pending. So the default first one is going to be pending. I'm just going to close the display here so we have a more real estate on the screen. Okay, so we define the status field with the choices, status options, and then when we create a new option, we're going to set it to pending as default so that we don't need to manually specify pending every time we create a new one. Then we're going to link our AI request to our session. So we need to be able to access all of the requests that were as part of a session in order to be able to group all of the messages that were sent and received. So I'll show you how you do the grouping and everything later on, but for now, we're just going to do session equals models.foreign key, and then we'll pass in the AI chat session. On delete equals models.cascade. I'll explain what that means in a moment. Null equals true, and then blank equals true. Okay. We'll just type out the rest of the field, and then we'll go through all of them, and I'll explain what all of this does. So we'll have messages equals models.json field, and we'll have a response field equals models.json field, and this will be null equals true, blank equals true. And then we'll have created at equals models.date time field, auto now add equals true, and updated at equals models.date time field, auto now equals true. Okay, so we've already talked about the status option, so we won't go through that, the status field. The session field is the ID used to store the ID of the session that this AI request is part of. So we specify here a foreign key. This is all on line 33. A foreign key, and then line 34, we have the AI chat session, which is the model that this is going to be linked to this AI request. And then on delete models equals cascade, that just means if we delete the session, it will automatically delete all of the AI requests for that session. And then we have null equals true and blank equals true, which means we could, in theory, create AI requests without a session. And this could be used for if you wanted to use AI for something else in your application. For example, part of a chat flow, but you instead wanted to use AI to summarize some content or something like that, then you could use the same AI request model for that and reuse it in your code. So this is how I like to set these projects up. Then we have messages. So that's going to be used to store all of the messages that will be sent to the AI API. So that's the array of messages, which we'll look at in a bit more later on. And then we have the response. So this is going to start off as null because when you first create, the request is not going to have a response. But once OpenAI return a response, it's going to be stored in the response as a JSON field. So that's the JSON content from the response. And then we just have the created at and updated at that I like to add in order to keep track of when things were created and updated. Okay, so now that is set up, make sure you save the file, and we'll go ahead and create our Django migrations for applying these changes to the database. So the way that we do that is we're going to do it by running the Django make migrations command through Docker Compose. So I'm going to type Docker Compose run --rm, and this is just to remove the container once it runs this command, just in case you're wondering why we pass in the rm. And then we'll type the name of the service, backend, and in the last command I just started the Python bit here, but usually I like to wrap it in sh-c python manage.py make migrations. And the only reason for doing that is just makes it clearer what is the Docker syntax versus what is the command we're running inside Docker. So we'll run make migrations. This will tell us if any errors occurred, if we have any typos or mistakes in our code. One common thing people do is they miss commas in the tuple here. So if you do that, then just go back, double check all the commas and everything. You can see a version of this on our website with all of the code if you just wanted to copy and paste things. We have that available on our website, which we'll link in the description. So now that we've created our migration file, you can see if we look at all the changes to the project here, we have this auto-generated migration file, so we don't need to touch that for now. This is just part of the Django system and how it manages database models and stuff. So the only thing to do now is we need to edit our Django admin so it includes these new models. So we'll do admin, we'll open up the admin.py file that's in backend /core/admin.py, and then we'll type admin.site.register models.py AI chat session and admin.site.register models.ai request. Okay, so we'll save that, and then if you go ahead and stop the development server if it is running, if it's not running, you of course don't need to stop it. If it's running, stop it, and then type docker compose run, docker compose up -- watch. And watch just is something for the front end to essentially reload changes when they get made. The reason why we stopped and started the server again is so that the migrations are applied. If you look in our Docker Compose, as we showed when we went through the Docker setup in the previous tutorial, we have the migration command here that will run the migrations every time we start the service. So if you open up the browser now, if I can just find my browser here, open that up, and I'm already still logged in. If you refresh, you should see these new models appear here, which are the ones we just added, and they allow you to add new items and so on. Okay, so that's everything we need to do for the database setup. Let's go ahead and commit our changes. Git add.git-am added database setup. And now we'll move on to the next step. Okay, so the next step is that we're going to configure OpenAI so that we can have an API key in order to make requests to the API. So the first thing we need to do is create the API key. So if you open up the browser and you head over to platform.openai.com/API keys, assuming that you already have an account and you're logged in and you set up the billing and everything like that, you should see this page here, which allows you to create new API keys. So the way you do it is you click this button here called Create Key, and then you just give it a name. And of course, you want to make sure you don't share this key with anyone else, because anyone with this key can make requests to your account at your cost. So just make sure you keep the key secret. It's called a secret key for a reason. And you're going to go ahead and just give it a name. So you can call it Chatbot. I've already got one called Chatbot, so I'll call one Chatbot 2. And it needs all access because it needs to be able to make the request. You could actually specify restricted access and give it requests just to the chat API, which is this chat completion one. So you could actually give it just write API to this. I'm just going to use it all requests just to keep it simple here. And then we'll click on Create Key. It will show you the secret key, which, as I said, keep it secret. I'm obviously going to delete this one after I've shared it on the screen. And then you can copy it to the clipboard, and you want to make sure you store it somewhere. So we can go ahead and store that right now in our project in a configuration file that we're going to call .env. So if you open up the project, and inside the project here, you're going to create a new file called .env. This is an environment variables file, and you can see that it's kind of grayed out here, and the reason is because it's included in our git ignore. We do that because this is where we're going to store the key, and we don't want to commit that to our git project because it's best practice that you don't commit secret keys and things like that to a git project. So we can specify it here just for our local project. If you're working on a project with multiple people, then you probably want to have different keys for different people so you can keep track of who's charging what to the OpenAI endpoint. We're going to specify the name of the key here called OpenAI_API_key equals, and then you can paste in, that was the wrong clipboard paste. You can paste in the key that we've created here as a value there. So you paste in the key, you save the file, and then just keep that secure. Make sure that nobody else has access to that. Of course, don't leave it on a shared machine or anything like that. And then we have our API key set up for interacting with the chatbot. So the next thing we need to do is pull this key into Django so we can access it. So we've set the environment variable in .env. So now we're going to open up docker compose.yaml, and we're going to add some environment variables to our project. So we need to add it to our backend and also our worker task. And that's because these could potentially both need access to the OpenAI backend. So we'll add a new variable inside backend under the environment block here. Underneath Celery broker URL, add a new line, do hyphen, and call it OpenAI API key equals, and then we're going to use this syntax here, $ and then the curly braces. We'll type the same variable name again. So OpenAI_API key. And the reason why we do this is because it tells Docker Compose we're going to set an environment variable in our backend service called OpenAI API key, and we're going to set it to the value of the environment variable on the host machine with the same name, OpenAI API key. And what this does is Docker Compose has a hierarchy of places it looks for this value, and one of the places is the .m file in the project. So it's going to check the .m file is going to find a key called OpenAI API key, and it's going to match it here, and it's going to set it as the environment variable here. So we also want the same variable to be available in our worker, which is going to be actually making the request to the API backend. So you can set that there and then save the file. And next we need to set this variable inside Django. So if you open up backend/settings.py, scroll to the bottom here, we'll just give it the same name again, OpenAI API key equals os.environ.get, and then the same key name here. And that will pull in the variable from environment variables using the os.environ module, and it will set the value in our settings.py as the OpenAI API key. Okay, so once that's done, we're going to add the OpenAI library to our requirements.txt. This is the official library from OpenAI for interacting with their API. So it's called OpenAI, and the version we're going to use is 1.61.1, and that's just the version that I'm using. It was the latest version at the time of making this video. I recommend you use this specific version as always, just because it means the steps are going to be exactly the same, and then you can always upgrade at the end if you want. Okay, so once the requirements.txt is saved there, we're going to save it. One other little thing I'm going to add to the project is just a Python version, so .python-version. And this is just if you're creating a local environment variable and stuff, just to make sure the version that we're creating it in is matched. This is used for a tool called PyEnv that I use. It's optional, you don't have to do it, but I'm going to add it here anyway to make sure we use a consistent Python version. And then that's everything we need to do to set this up. So we can go ahead, open up our terminal, do git add git commit -am, added OpenAI integration. And we also want to run pip, just make sure that you're in your virtual environment here, and we can do pip install -r requirements.txt just to install this new requirement that we've added. And that installs it in our local environment, local Python environment, which is in our project, just so Visual Studio Code has access to the IntelliSense features. And then we need to install it in our Docker image. So we do that simply by typing docker compose build, and that will rebuild our Docker image and install this new requirement there. So if we open up Dockerfile, you can see that we have a line here for pip install. So now we've gone ahead and installed the OpenAI library and configured our project to be able to use it, we can move on. So now that we've set up our project to use OpenAI and to be able to have access to the OpenAI API key, we can move on to actually making requests to the AI backend. So let's go ahead and do that, and I'm going to add the logic for most of this inside the models. And we're going to open up backend /core/models, and here we have our models, and inside our AI request model we're going to add some logic which allows us to actually make the request to OpenAI and give a response. What we're going to do is add something called a handle method, and you can really call it whatever you want, but I'm going to call it handle. And what this essentially does is it handles the request. So I'm going to just minimize that there so we have a better screen. I'm going to type def handle and then self. So that's just a simple method we're adding to our AI request model. And we're going to type in the doc string here, handle request. So this essentially will handle the request to OpenAI. So we're going to start by updating the status to running. So once we've called handle, it's going to change the status of the model to running. So we'll type self.status equals self.running. And then we need to save the model. So we'll do self.save. Okay, so we've updated the status. Now we're going to create an instance of an OpenAI client. So if we scroll up to the top of the file, we need to add an import here. We'll add an import right to the top above Django.db, and we're going to do from OpenAI import OpenAI. Okay, so now we can create an instance of this client. So we'll do client equals OpenAI. And the client's actually configured, if you look at the documentation for the official client, which I'll put in the description, it's configured to automatically pull the environment variable with the name OpenAI API key. So we don't actually need to pass that to it directly because it kind of happens just automatically from the environment variables, which is quite handy. So then we'll type try : completion equals client.chat.completions.create. And we'll type in model equals GPT-40-mini, and then comma, messages equals self.messages. And then we'll do underneath this self.response equals completion.toDict, and then self.status equals self.complete. And we'll handle the exception block here by typing except exception : self.status equals self.failed. And I'll talk through all of this does after we typed it out. And then finally, at the end of the handle function, so kind of level with all the other code here, make sure the indentation is correct because it's very important with Python projects. We're going to type self.save, and we're going to save the model. Okay, so we'll run through what this handle method does. So it starts, as I said, by setting the status to running so that we know that this one is actually running right now, and we have that visibility in the Django admin, and we can also use that for other logic in our code. We create an instance of the OpenAI client on line 50 here. Then we have the try block that starts line 50, ends at line 59. And essentially what we're doing here is we're trying to make a request using the completions API. So on line 52, we have the completion, which is going to be the variable for the output, equals client.chat.completions.create. So this is the API call for creating a new request for the completions API. Model equals GPT-40-mini. If you remember when I was talking through how the requests work, you specify which model you wish to use, and you can choose any of the different models. They have different levels of capability. So some are a lot smarter, some are more lightweight and cheaper. And of course, you are charged for the request based on the model that you chose to use. So we're using what I believe is the cheapest model available, which is GPT-40-mini. And then we're setting the messages here. So messages is an array, a JSON array, or in Python, it's a list. So self.messages will access the messages that were created on the request, and it will put them in the completions request here. So what this does is we can provide, when we create an AI request, provide a list of messages, and that will pass that to the completions API. Then we're getting the response, and we're setting it in the response field, which is on line 42 here. So essentially the response will store the response from the API, which will allow us to extract the content of the response from the response object. So because we're storing the response in a JSON field, I'm calling the toDict method here on line 56, which converts the completion response to a dictionary. Dictionary object is the Python object that matches essentially an object in JSON. So we have it as a dictionary. That means we can set it to the response. And then on line 57, we're updating the status to complete, because now if we get to this stage in the code, if we get to line 57, we can assume that the request is complete and we have an actual response. And then line 58 and 59, we're handling all of the exceptions that may occur. So really what I would do in a real project, if I was doing this for a client, is I would handle these exceptions more explicitly. So I would find out what exceptions could possibly be raised, and I would handle them specifically instead of just catching all the exceptions. However, this works fine for this demo. Essentially, if we have any exception, then we can assume the request has failed. You could also at this stage capture any information about why it failed. So you could say it failed because the request was rejected or the internet connection timed out or something like that. But we're not going to do any of that for the purposes of this tutorial. We're just going to catch all the exceptions and then set the request to failed if that happens. Okay, and then finally on line 61, we're saving the updates to the model. So if it's been successful and we have a response set on self.response as line 56 and 57, then it will save that information. Otherwise, if we got to line 59 because it caught an exception, then it will save the status as failed. Okay, so now we can save that file just to make sure our updates are saved. The next thing we're going to do is handle the job using a background task. So as I mentioned, it can take quite a while for these requests to be fulfilled. And when I say quite a while, I don't mean like hours, but it can be seconds, multiple seconds, which typically you want to handle requests like that using asynchronous tasks, so you're not blocking the kind of main thread of the application. So what we'll do is we will open up our Explorer here and go to backend /core/tasks. And as I explained in our tutorial for adding Celery to Django, this is where you add your asynchronous background tasks. So we need to add a task for handling our AI requests. So below Celery here, we're going to do from core import models so that we have access to our models. And then I'm going to add a new function inside this tasks module here. And we'll use the decorator shared task. As I explained before, this is how you define a Celery task in Django. And the project's already set up for this. So if you're interested in knowing the details, please go and follow our adding Celery to Django tutorial. And then we'll do def handle AI request job. And we'll accept one argument here called AI request ID. And we'll do colon. And we'll just type models.ai request.objects.get ID equals AI request ID dot handle. Okay, so essentially this is just a wrapper around our handle method, which allows us to call it as an asynchronous task. So this is really just how I like to create the background tasks in Django. I like to keep them very minimal and then have all of the logic inside the model. So that's essentially what I'm doing here. We have the handle AI request job, which is what is run by our background task. When we create a new task, we're going to pass in the AI request ID, and that's going to be the ID of the AI request that we want to run the background task for. And then we call models.ai request.objects.get, which is used to get an instance of a model, getting it by its specific ID. So ID equals AI request ID. And then we're calling .handle, which is the method that we created here. So it'll run this code inside the background task. Okay, so now we have the logic for making the request, and we have the background task configured to call this handle function, or method, I should say. What we're going to do next is add some logic so that every time we create a new instance of this AI request model, it will queue a new job to run the handle method. The reason why we do that is because the whole purpose of AI request object is to make a request to OpenAI. So we can automatically run this handle method as a background task every time we create a new instance. So what we'll do is we'll add a new method above the handle method called def underscore queue underscore job self. I'll type it out and then I'll explain it, and we'll add the docstring add job to queue. And all this will do is call handle underscore AI underscore request underscore job dot delay, and then it will pass in self dot ID. And we just need to import this handle AI request job from our background tasks. So again, at the top of the file, we'll add another import. We'll do from core.tasks import, and the name here, handle AI request job. We'll scroll down And you can see here, essentially what we're doing is we have a method, we have it prefixed with an underscore to make it a private method, and that we don't want anyone to call this outside of this actual model code. And then we're calling the handle AI request job dot delay, and then the ID of this object. So dot delay is just used to signal that we want to queue this as a background job instead of calling it directly. So if you were to just call it like that, then it would actually not run it as an async task, it would run it synchronously. So it would run it straight away and block the kind of main thread. We do dot delay, which is how you kick in that process to add a new job to the queue, and then the job is handled when the worker gets availability to handle it. Okay, so we've added this, and now all we need to do is trigger this to run whenever we create a new instance of this model. So we can do that quite simply by overriding the save method that's available on Django models by default. So def save, and then in the arguments self, and then keyword args, colon. And now what we can do is call is underscore new. So create a variable called is new equals self dot underscore state dot adding. And then if is underscore new colon self dot underscore queue job. Okay, so what we're doing here, and I actually missed a very important bit. So underneath is new, we need to type super, open and close brackets, dot save, keyword args with the two asterisk symbols here. Okay, so the save method is called automatically, or it's called whenever we want to save the method. So you can see here, like on line 67, for example, we're saving updates to this object. It's also called when you create a new object. It's called both times whenever you update or create an object. So we don't want to run a new request every time we update the object. We only want to run it the first time we created the AI request. And that's because if you made it run every time you saved updates, then it would just keep running forever essentially, because you would call handle and then it would get a response and it would save either success or failed, and then it would run again because you called the save and then it's queuing a new job and so on. So to avoid that, we add some logic here to say is new, and there's a way of checking in Django whether you are adding a new model, so this is the first time a save has been called, or if you are editing an existing one. So we'll do that by calling this self._state.adding, and that will tell us if this is a new model. So if it is new, we want to keep track of that. On line 71, we're calling super.save, so that calls the logic for the default save method as if we hadn't overridden it here. So just make sure that the data is actually saved. We're passing in these keyword args, which are any additional arguments that are passed into the save method. We check if is new, so if that's true, then queue the job for running this. So that calls our method that we added here, which adds a new request to the queue of requests, which will then go ahead and run the task, which we'll call handle, which will take us back in here and run this as an asynchronous task. Okay, that's great. So now that's done, we can actually test our AI requests. So we can test it by creating a new AI request through the Django admin. Now, because we didn't actually make changes to the structure of the table, we just added some methods to our model. We don't need to rerun our migrations. So just make sure you've saved the files here. And then let's go ahead, make sure that the server is stopped, because you can already see I've got some errors here because it's not installed OpenAI. And then we're gonna run docker compose up by the pass in build and -- watch. So build essentially tells it to rebuild our images, which we need to do because we need to install the OpenAI client. We actually already rebuilt it, so we probably didn't need to do that, but just to make sure, pass in the build so it rebuilds. And then it will start our server again, so we can open up the browser. And I'm just gonna close this since we don't need it anymore. Head over to localhost /8000. It'll take you to a page like this. And we could create a new request object here. So I'll try and make this a bit bigger so you can see it on the screen. So we'll create a new AI request, leave status pending. Session we'll just leave for blank for now. And then messages, we're going to delete the content there and we're going to type in manually some messages here. So we'll add the open and close the square brackets because it needs to be an array. And the first one is going to be open and close the braces here, and then we'll add a string called roll. We'll test some text called roll in a string, colon, system, and then comma, and then content, quotes, colon, and then we will add some content here, and we'll just kind of for a joke, we'll make it be, or we'll tell it to act like this. So we'll say, you are a snarky and unhelpful assistant. Of course, in the real world, you probably don't want it to be a snarky and unhelpful assistant. I'm just trying to demonstrate how you can get it to respond in a custom way. So in reality here, you would put in however you want the chatbot to respond, which is relevant to your application. We'll add a comma here. So we've added the kind of role content object here, and then we'll add another object with role, and then user, comma, and then content, and we'll add in how are you today. Okay, so this is going to create a new request, or at least it should if everything works. Create a new request with the setup prompt here, the system prompt, you are a snarky and unhelpful assistant. And then in the role user, we're going to specify a message like, how are you today? So this was the kind of, as if the user had just typed in, how are you today, into the chatbot. Hit save, and it creates a new object. You can see it's already complete, so that actually happened really fast. So I wonder if, oh, it did return a response here. I guess they just sped up the AI API quite a lot. So it responded almost instantaneously. If you scroll in the response, obviously this is quite hard to read. So what I'm going to do is copy this, open up my VS Code, create a new window, paste it in, and I'm going to format this format document so we can see this. It looks nice. Okay, so you can see here, it's got all the context of the response from the AI. This information, the usage information, can be used to calculate the tokens. If you remember, I think we said it charged 15 cents for inputting a million tokens. We used 28 tokens, so quite a lot less than the million. And it charged 60 cents for returning 1 million tokens, and we got 29 tokens back here. Okay, so you can see here how it responded. It said, oh, you know, just existing in the digital ether. How about you still trying to figure out how to be a functioning human? Okay, so you can see it's doing exactly what we asked, which is returning as a snarky and unhelpful assistant, which is great. So now that's set up, we can basically move on. Let's go ahead and commit this to our project. So we'll just do git add dot, git commit, and then handle AI requests. Okay, that's great. So now that's set up, let's go ahead and move on to the next step, which is managing our chat flow. So what we need to do is add some logic that handles actual chat prompts and keeps track of all of the context from all of the previous prompts so that it kind of builds up the context over time. So again, we're going to add our logic into our models.py file. So I'll just clean all of this up to get rid of this. I can't stand having multiple tabs open. So we're going to open up backend/core/models.py, and we're going to add the logic this time to our session. So we've added the logic for handling the request. Now we're going to add some kind of higher level logic which manages those requests in order to create some kind of chat flow. So the first method we'll add is just a method which gets the last request in the session. So the last request is important because that's going to have the latest list of messages that we can access, or that forms the chat flow. So our logic is going to essentially be getting the last request, taking all of the messages, inserting the last response to that, and then creating a new array, or in Python, a list of messages that we can send for the next request. So we'll start by getting the last request. So we'll type def get underscore last underscore request. And then we'll just put in self there because this is a class method. And then we'll do return the most recent AI request or none, or nil, or null. Essentially, the reason we do that is because if this is the first session, well, there isn't going to be any last request because it's the first one, so there's no request so far. So we'll type self.ai request underscore set dot all, and then dot order underscore by, and then minus created at dot first, open and close brackets. Okay, so this gets the last request. The syntax here is it calls the AI request set, which is set automatically, even though we don't actually have it set explicitly here, it gets set up automatically by Django because it's how you access the reverse relationship of the session here. So because we have this session foreign key, we can call AI request set, which is all of these AI requests that are linked to our session. And the underscore set is just the automatic syntax that is set by Django. You can customize the name of this in case you're interested by typing the related name field here, but we're not going to do that. We'll just leave it as default because we're quite happy to just leave it as AI request set. So we're getting all of the requests that is linked to this session by calling the .all method. And then we're doing order by negative created at, which says order by created at in reverse order. So then the first item should be the most recent item. We're getting them all, and we're getting the first of the items when ordered by created at. So this returns the most recent request in this session. And by default, the .first method will return none if there are no results. Okay, so next what we'll do is we'll add a kind of a helper method for creating the structure of a message. So we'll do def underscore create underscore message self message role equals user, and then create a message for the AI, and then return role and the role and content and the message. Okay, so it creates a new dictionary with the correct structure for a message. We're defaulting to user because that will be the main one that's set. In this message, it will be messages from the user. So it just is a helper thing, so we don't have to type this every single time we want to create a message for the AI backend. Okay, so now what we need to do is create the first message. So the first kind of logic we handle is if this is a new chat session and we're sending the first message. In the first message, we need to create the system prompt and define that here. So we'll type def create underscore first underscore message self message create the first message in the session. And we'll do return, and we'll return a list here, self._create message, and we'll type in, you are a snarky and unhelpful assistant, and we'll override the default role of the user and change it to system, because this is the system setup message, and then we'll add self._create message, message, comma, user, so then it will add the user's message in below this. So we're imagining that we don't need to call the setup until the user actually sends the first message. So when the user sends the first message, we'll create this first message, we'll pass in the message that the user typed, and we'll create a new set of messages that starts with the system setup message. And as I said, as you can see, this is how you set it up to respond in the way that you want. This is a very short prompt. You can make this prompt really big, and you could provide all kinds of information and context relating to your specific use case. So this is where you would set it up to respond in the tone of voice that you want. You would tell it what it can do and what it cannot do. If you've ever seen these things online where people interact with chatbots on certain company websites, and they get it to do things like create a Hello World project in Python, which isn't really related to the kind of user support situations that it needs to do. That's because they didn't define properly the prompt that says don't respond with example source code things that people ask, just only respond in this way, only be a support bot. If they ask you to do anything else, then tell them, sorry, you're not able to help with that. So that's where you would put all of this information in the system setup prompt. I've only got one here. You can add as many of these as you need, obviously within the limits of the request, but you keep customizing it by adding multiple system setup prompts here. We're just going to add one, keep it simple. So this is basically the setup that we need in order to get the messages that we need to send. Next, we can actually compile the list of message history for an existing session. So we'll do that by typing def messages self, and we'll put the docstring here, return messages in the conversation, including the AI response. So it's kind of where we pull everything together in order to get a full history of the messages that we can show in our chat interface. So we'll type all underscore messages equals a new list, an empty list, and we'll do request equals self dot get underscore last underscore request. So we get the last request, and now we have some logic here. We'll type if request all underscore messages dot extend request dot messages try all messages dot append request dot response choices 0 messages, or message, sorry, not messages. And then we'll do except key error, type error, index error. And if that happens, we'll do pass. And then we'll do return all underscore messages. Okay, so the logic here that we've added is this is a method that is on our session that will allow us to get a list of all the messages that have been sent and received to and from the AI. So we start with all messages and we define an empty list here. The default starting point is an empty list if it's a new session. And then we get the last request on line 43, the last AI request that was made for this session. If there's a request, so if there is any request, if it's not none essentially, then we'll extend all messages by the request.messages. So that's the list of messages that were sent in the most recent AI request. We're going to extend out all messages by that, which means essentially add to the current list. And then we'll do this try block here. So what we're doing here is we're getting the response from the last AI request, and we're extracting choices, then the first result in choices and message. And I'll show you why that is. I closed off the example before, but let's just bring that back here. So this was the example response that we got last. We'll format this document again. Okay, so you can see here that we don't necessarily care about usage right now. This is just if you wanted to calculate cost. What we care about here, the most important thing is the choices. So choices is the key in the root of the object here. And then it has an array essentially. So we want to take the first choice. I believe they did it as an array because maybe different API endpoints return different choices perhaps. I'm not exactly sure, I've not experienced that myself. We just want to take the first item in the choices, which is why we have the 0. And then we want to extract the message from that. So the message includes the role and the content of the response. So we extract that and we do that here. And just in case the structure is not as we expected, we handle the key error, type error, and index error. So we might get a key error if the key that we tried to get is not found. For example, they don't have choices. Or we might get a type error if we tried to get the key on a null response. So if the request.response was null or empty, then it would give us a type error saying you cannot use this syntax to extract a key on something that is not an array or not a dictionary. Index error, we might get that if choices was empty. So these are a few kind of cases we might get these errors. So we're just handling that and we're just passing for now. In reality, you might want to log a warning or something to the screen so that you can see that. But for now, we'll just do pass. And then we return all messages. So this is essentially how we combine the latest list of messages with the last response, and then we return that, and that gives us the all messages essentially. Okay, so next we need to add one more method to the session called send, and this is going to be used to send messages as you would expect. So def send self, and then we're going to accept the parameter message. We'll add send a message to the AI as a doc string here. And again, we'll get last request equals self dot get last request. This will be used, I'll explain what all of this does after we type it out. I'll go through it all. We'll do if not last request, AI request dot objects dot create session equals self, message equals self dot create first message, and we'll pass in the message. Okay, so that calls create there, and then we'll do elif last request dot status in AI request dot complete AI request dot failed. In this case, we'll do AI request dot objects dot create session equals self, messages equals self dot messages plus, and then another list here, self dot underscore create underscore message user. Okay, and then we'll just do else return. So we have kind of three states here. So what we're doing here is we define a send method, which you use to send messages, very handy on the session. And then we'll do last request, so we'll get the last request. The main purpose of this is to try to determine, are we sending the first message in the session or are there existing messages? Because that changes the behavior on how we want this logic to run. So if not last message, maybe this is a confusing way of putting the syntax, but if not last message means if there are no last request, then we're going to assume this is the first request, and we'll create an AI request object using AI request.objects.create, passing in the session, which is the self, because self is we're doing this on the AI chat session model. So self would be in the instance of the session. And then we send messages, and I actually noticed a typo here. It should be messages plural, and make sure I did the same. Yeah, I did it correct in that one. So the messages will be the create first message. So essentially we create the first message by calling this create first message, which will return this. So it'll be the setup prompt, the system prompt, and then it will be the message that the user provided. Okay, so that handles the case for the first message. The second case is the elif here, where we have on line 62 to line 68. If there's no last request, so the request, this is the first request essentially, then we're going to check the status of the last request. So we'll check if the status is either complete or failed. If the status is not complete or failed, so if it wasn't complete or failed, it would have to be either pending or running, then we don't want to do anything. We don't want to allow the user to send a new message before the last message has been completed, because that will mess up the flow of the logic and the list of messages that is sent. So we want to make sure that we are only using the last request if the request is complete or failed. And if that's the case, then we can create a new AI request, and we'll pass in again the session self, and the messages will pass in self.messages plus, and we'll create a new message here. So we'll pass in the existing messages plus the new message that we want the user to send. So it calls this existing messages method here, which allows us to add up the messages with the last response, and then it creates a new one with the user's latest message. If we get to this line 70, we just return a none. You might want to throw an error or something, say you cannot send a message while the last message is pending or something like that. But for now, we'll just return an empty response. Okay, so that's the send method. One thing I noticed is that I forgot to return the result from get last request. So good job if you spotted that. If not, then let's go ahead and fix that now by typing return on line 24 here inside our thing. I think it's because I've been working with Ruby, which doesn't require you to return. So that's why I forget to do that sometimes, which is frustrating. But just make sure you add return here so that it actually returns the result. And again, good for you if you spotted the error. Okay, so now that's all created, we can go ahead and test this in the Django console, or the Django shell, I should say. So if you open up your terminal, and you can leave it running if it's already running, because then we can check things in the Django admin. What we're going to type here is docker compose run --rm backend sh-c python manage.py shell. Okay, so we start a new shell. We're going to do from core.models import AI chat session, which is the session model. We'll type session equals AI chat session dot objects dot create. This will create a new session, and then we'll do session dot send and then hello. Send that, and then we'll go ahead and look inside our browser. So we'll open up the browser to the Django admin page, and if you refresh, you can see we have the sessions in here. This is our new session object, and then AI requests. We got the new object here. So you can see we already have a response. So let's go ahead and test the session logic by doing session.messages, and it should give us a list of all the messages. So you can see the system one was sent, and then the role user content hello, which was the first message we sent, and then role system content. So the response was, oh joy, another person who needs something. What now? You can see again, it's keeping up its strong persona of a snarky and a helpful assistant. So now we can send a new message to say like session.send, and we can ask it something like, how are you? And we'll see what it responds. So we'll wait a second for that to process. We can check here. You can see that it's responded already. So we'll do session.messages. Again, we should see the list of messages building up as we go. So we got the starting one, then the content hello, which was the first message we sent, and then their first response. Our next message, which was how are you? And then its response, which was, I'm just a bunch of code, so I don't have feelings, but thanks for asking. How can I assist you on this obviously thrilling day? Okay, great. So now that that's done, we have working session logic. We can type exit, open, close brackets there, and do git add dot git commit -am, and I'm going to commit the changes, which is add logic for chat session. Okay, so next we're going to add our API for being able to make requests to this session management process that we've set up. So if you open up the code, we're going to add this using Django REST framework. So again, I'm just going to close off these tabs here. We're going to start by creating a serializer, which is going to be used for our responses. So if you go into Explorer, and we'll create this inside core, we're going to create a new file here inside core called serializers.py. Okay, so this is going to be the thing in Django REST framework which handles the requests and responses to and from our API. So this is going to be the API used by our front end to communicate with our back end logic. So we'll start by importing serializers and the AI chat session that we need to use. So we'll do from REST framework import serializers, and then from core.models import AI chat session. Now, I'll give a quick overview of what we do as we go along after we type each class. However, if you want an in-depth knowledge about Django REST Framework, then we have a course specifically for that you can find on our website, londonappdeveloper.com, the Advanced Backend REST API course. Okay, so now we'll do class AI chat session message serializer, serializers.serializer, and we'll type role equals serializers.charfield and content equals serializers.charfield. So this is going to represent the messages that are sent to and from the API. So that will be the role and the content that is sent with every message and received from the messages from the AI chatbot. So it's a serializer for converting that to JSON and vice versa. Okay, now we're going to add a slightly more complicated serializer. So we'll type class AI chat session serializer, serializers.model serializer. And we'll do, I won't add a description here, we'll just talk through it. We'll do messages equals AI chat session message serializer, the one we just created, many equals true, so there's going to be a list of things. And then we'll do def2 representation, we've got an example here, self instance, that's correct, and then we'll do representation equals super dot to representation instance. Just make sure that matches there, yeah. And then representation dot, sorry, not dot, messages equals MSG for MSG in representation messages if MSG role equals, or sorry, not equals system. I'll explain what this does in a moment. We'll just type it out first. Return representation. And essentially what this does is it takes our instance and it gets the messages. So to representation is called anytime you want to convert a Python instance of the AI chat session serializer to the JSON representation of that instance. So it's what's used to convert the instance in our Python code to a JSON response that can be sent to our API. So we're overriding the default to representation method here. And the reason why we're doing this is because we want to extract, or we want to exclude system messages from the messages that are returned by the API. The reason we do that is because, as I explained before, the system messages are messages that are used behind the scenes to set up how the chatbot will interact with the user. So in most cases, you wouldn't want the user to be able to see the system set up messages. You only want them to see the messages that were sent to and from the chat that are either user or assistant responses. We're doing this here by calling the representation, the default representation. Super.to representation gets the default behavior of Django REST Framework to representation method. And then we are overriding the messages that are part of that. And we're setting it to an array, which is MSG, so message for message in the existing representation messages if the role is not equal to system. So it's just some logic to exclude all of the messages that are system messages essentially. Then what we're going to do is just define the meta class for our model serializer. So class meta, model equals AI chat session and fields equals ID and messages. And then read-only fields equals messages because they're going to be read-only in that you can't write messages to them. We're going to have a special API endpoint for sending messages. We're not going to allow them to send it by adding messages to the serialized request. Okay, so now that's done. Let's go ahead and create a view that uses this to actually add some logic. So open up views.py, and inside views.py, we're going to add the following. So we'll just clear everything that's in there right now. It's a default one created by Django. And then we'll do from REST framework import status, from REST framework.decorators import API view, from REST framework.response import response, and then from Django.shortcut shortcuts, import get object or 404. Should we get object or 404? And then from core.models, import AI chat session. And from core.serializers, import AI chat session serializer. Then we will do the first one, which is handling creating a session. So the front end needs to be able to create a new session like we did in our example when we tested it. We called session.objects.create. We need to be able to do that from the front end. So we'll do that using a special API called create chat session. So this is going to be a simple and a function-based API view. So we'll create it using the Django REST Framework API view. So usually I would set this up using a view set or something like that. But because we just want some simple endpoints for managing our chat session, I'm just going to do it the fastest way, which is to create a simple API view. We'll do that using the decorator here at API_view and then post. Okay, and then def create chat session request, create a new chat session, and session equals AI chat session.objects.create, and serializer equals AI chat session serializer, and then we'll pass in the session, and we'll do return response serializer, response serializer.data, and then status equals status.http 201 created. Okay, so that's our endpoint for creating a new session. It just creates a session and returns the serialized session, which it will include the ID, which is going to be used for us to poll the session. Okay, and then we're going to do another function-based API view by doing API view, and this one's going to support HTTP GET and post. And this is going to be the chat session management endpoint. So we'll do def chat session, and we'll pass in, or we'll accept the parameters request and session ID. And then we will do retrieve a chat session and its messages. And we'll do session equals get object or 404 AI chat session, ID equals session ID, serializer equals AI chat session serializer session, and then if request.method equals post, message equals request.data.get message, and if not message, return response error, message is required, and then status equals status.http 400 bad request, and then we'll do session.send message, and then we'll return response serializer.data. Okay, so one thing I noticed is that for some reason I use camel casing here when the Python convention would be to do it like this, session ID. So we'll just fix that. Session ID, that's just because I work in so many different programming languages that sometimes I get mixed up between which variables syntax is best to use. So we have the session ID here, and then basically what we are doing in this is we are getting the session or returning a 404. So they make a request, either a get or a post request with the session ID in the URL of that request. And I'll show you how we do this in a moment. We create a new serializer instance passing in that session. So this get object or 404 will return a 404 bad request or a 404 not found if the session ID is not found in the database. And then we pass in the serializer, or we get the serializer object here. So AI chat session serializer session. And then we check, is this a get request or a post request? So if it's post, then the user wants to create a new message, or they want to send a message to the session. So in that case, we get the message from the request on line 25 here. And if there's no message, we return a response that says error message is required with a status 400 bad requests. So this is just a little bit of error handling here. Probably much better ways of doing this, but I'm just doing a quick basic endpoint for managing chat sessions. If there wasn't a message, we would have returned on line 27, so we wouldn't go any further down in the method. If that isn't the case, then we'll just send the message to the session.send method. So that will send a new message. And then at the end on line 33, we return the response. So either way, whether they do a post or they do a get, they always return a response of the serializer data. So when it returns the response, it's going to return the session serializer response, which includes all the messages that have been sent to and from, which we can then use in the front end to show the list of messages. Okay, so the next thing we need to do is wire this up. I like to call it wiring up. We connect up this the new views that we've created to actual URLs. So if you open up backend/backend/URLs, this is where all of our URLs are mapped to views which handle the logic. And what we're going to do here is we're going to import in our views here. So underneath the existing one, we'll leave that there. That's just a little test one that we created earlier. We'll do from core.views import create chat session and chat session. So these are the two view functions we created in here. We're going to connect them up now by adding a new path above admin path API/chat/sessions. So this is our sessions endpoint. We'll map that to create chat session, which allows the user to create a new session by doing a HTTP post to that URL. And then path API/chat/sessions / and then we're going to accept the session ID here. So str:/session_ID, and then close the angle brackets / and then after the string, we'll do chat_session, which will map it to our chat session. So I forgot a comma here. Make sure you add the comma to the end. And then what this does, it just creates two new URLs. So we got API/chat/sessions. That allows us to create a session. And then API/chat/sessions /str session ID, which is the ID of the session we want to manage. So we can actually test this in the browser by going to, first of all, making sure your server's running. So mine is running and it should still be running. We'll type localhost, we'll go to 8000, which is where our backend runs, /API/sessions with an S, and I forgot the chat. I'm forgetting the URLs already. So /API/chat/sessions gives us the Django REST framework interface. We can then pass in an object here, or we could just do a post because this is creating a session. So we create a session, it's got an ID of 3. So we do /API/sessions /API/chat/sessions /the ID of 3. It takes us to the sessions API. If we add here message, hello, and then post, it creates a new message. We refresh. Eventually it gives us the response from the assistant. So then you can keep on adding messages here, message, say it again, let's see how it responds this time. Hi, refresh, you can see, yep, it obviously keeps track of the history because it's saying hi again. It knows that we've said it twice essentially, so that proves that we're kind of sending the correct context each time. Okay, so that's the API that we need. So now go ahead and save the code to our Git project by git add git commit -am added chat API. Now we can move on to the next step.
We're making too much noise.
Okay, so now that we have all of our backend set up, we can move on to implementing the changes in the front end to give us our chat interface. So we're going to be doing a few changes here to our project. If you look at the existing project, which we have running on localhost 5173, it's just the standard, slightly modified response page from the default React project. So we need to customize this to show our lovely chat interface. I'll caveat this with, I'm certainly not a designer, so the interface isn't amazing. It's just very simple, very basic. I'm sure other people could make it look far, far better than the one I create here. I just wanted to create something very simple. Typing out lots of CSS isn't really my favorite thing to do, but we're gonna go through it here. In the links of the description of the video, you can get the code where you could just copy and paste it if you didn't want to go through all of the kind of CSS changes that we're gonna make to the project. So let's go ahead and get started. We're gonna start by opening up the project again. And we'll close off these Python files because we should hopefully be done with Python unless there's any errors that we added. We're going to open up front end and we'll start by just making some kind of minor changes to the overall CSS for the site. So if you go into src, open up the index.css, and again, this is the default CSS which is created for the project. We need to add some new lines in here. So we're going to find body here. And just above, in between the body and the kind of links that they have here, we're going to do HTML, root, and then the square braces, height, 100%, and width, 100%. And all this does is it means the HTML wrapper and the root object that the React application loads into has maximum height of 100% essentially, so it takes up the full screen. And then we're going to modify the body here. We'll delete flex, so we'll just have it use the default kind of inline div, and we will have a height of 100%, and then a width, width and a height of 100%. And again, the only reason I do this is so that I can put the chat across the full screen, essentially. Okay, so now that we've done our index.css, we can go ahead and modify our app.css, and this will be the CSS for the kind of whole application, essentially. So this is where the most of our styling is going to be done. So just clear the entire file, essentially, because we don't need any of the default stuff that's in there right now. And then what we're going to do is we're going to add the asterisks here, box sizing, border, box, and then dot wrapper is going to be the wrapper for our entire input. This will be full screen, so height 100%, width 100%. Again, if you don't like typing out CSS like this, we have the full source code available, which you can just copy and paste from, linked in the description and also on our blog post on londonappdeveloper.com. And then we're going to have display flex, justify content center, align items center. So pretty standard CSS class, takes up the full screen, the full 100% width and height. We're going to use flexbox to position our child elements. We're going to justify the content to center and align item center, which essentially centers everything both horizontally and vertically. Next, what we'll do is we'll add a chat wrapper. So we have kind of the whole wrapper for the whole component and then .chat wrapper. I will caveat this with I'm not an expert in CSS. I'm sure there's other people who could make this CSS a lot nicer and a lot sharper and a lot better to format, but this works for what we need. So we've got chat wrapper, and this is going to be the wrapper of the specific chat components. So this will be width 80%. It's just so we have a bit of a margin buffer. Height 80%. Find the percentage there. And then display flex, flex direction column, justify content, space between, and box shadow. And this is just kind of a nice little style we can add. So 0, 0, 20px, RGBA, 0, 0, 0, 0.15. And then we will do border radius 12 pixels and padding 10 pixels. The wrapper for the chat here is essentially going to take up 80% of the page, so we're going to have that 20% margin on either side. We'll use display flex to lay out the components, and we'll set the flex direction to column, which means all of the items will appear, all of the child items in the chat wrapper will appear in a column, and we'll justify them with a space between. So that means that they're evenly distributed with space between them based on the size of their contents. We got the box shadow here, which just adds a bit of a drop shadow to around the chat wrapper. It gives it a simple effect. And then the border radius, just to give some curved borders, because who wants square borders nowadays? And then you've got the padding, which is 10 pixels, just another thing to add a bit of space to make things look nice. And then we have .chat history, which are going to be the history of the chat, as you would expect. So it contains all of the chat log. Height, 100%. Margin, 10 pixels. So just, again, a bit of buffer there. Overflow, auto. Display, flex. Flex, direction, column. And then flex, direction. I've duplicated that in my code here, so it should actually be flex direction, should be flex direction, column reverse, and then overflow anchor auto. So what this does is it contains the chat history. We're gonna have a height of 100%, so it fills the space. Margin 10 pixels just for some space. Overflow auto, which means when the content gets larger than the parent size, it will add scroll bars essentially. So you can scroll the chat history when you get more messages than can fit in the window. Display flex is just my favorite layout that I know the best, so we'll keep using that. Flex direction column reverse, which means it's a column, but we're going to reverse it so new items appear at the bottom. Basically, elements in it start from the bottom and go up. And again, this is to get that chat effect where you have the items in there and then they kind of scroll, and then overflow anchor auto, which means that when new items are added, we automatically anchor them to the bottom of the div, which means that it will keep the scroll focus to the latest messages at the bottom of the chat, as you would expect in any kind of standard chat experience. Okay, so now we just add a bit more styling for messages. So we got the history, we want to style a message, so .message. In case you're wondering, this kind of nested CSS is supported in CSS3, so you don't need to use Sass or anything like that to get this. This is just native CSS. Message here, background color, we'll do FO, 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 which is one of the shades of gray. And then padding 10px and margin 10px, and then border radius 10px. So again, no square borders here. We're going to have curved borders, and we're going to have some space here to make the messages look nice. And then we'll add .message.user, and this will allow us to kind of show alternating colors for messages from the chatbot versus messages from the user. So the only thing we'll change here is just the background color. We'll do background color. Let's do, I actually have an example that I'm doing here is B4 DAFF, which is a nice color that I memorized there. You could change this to whatever color you want. This is just a shade of blue essentially. So you have gray for chatbot and blue for user. Okay, now we just need to style the input. So what we'll do is add a space here. So leave these two closing brackets here, and then we'll add input, which is just the text field that the user will type their message into. We'll type width 100%, so it's going to fill the width, and it's going to be padding 8%, or sorry, 8 pixels, I should say, and then border 1px solid, and then hash CCC, again, just a shade of gray there, and then border radius 4 pixels, so no sharp edges here. Now we can go ahead and start building our component inside our React app. So if you open up frontend/src/app .jsx, and we will go ahead and clear most of this out. So we don't need any of this. This was from the example that we had before where we were testing our integration with the Django REST Framework backend. We did all of this in the previous tutorial. If you're interested in how this works, you can take that, which we'll link to in the description. So what we're going to do is we are going to also remove this React logo and stuff. We don't need that. We do need the CSS. That's the CSS we just modified. Use state here we'll leave because we will use that. And then we're going to clear out all of the contents of our return value here, including that. Okay, so now we have more or less an empty component. So we'll start building this up here. We'll go div class name equals wrapper, and then div class name equals chat wrapper inside that, and then div class name equals chat history. And then we'll do just another div, and it's going to contain all of our messages here. So we'll just do to-do messages because we're going to need to get those messages. What we'll do next is below this, so somewhere around here. So inside chat wrapper, we want this adjacent with the chat history, the input box. So we'll go input type equals, I'll break this onto multiple lines because it could be quite long. So type equals text, and then placeholder equals type a message, 3 dots or an ellipsis, value equals message, and then on change equals E for the event, set message e.target.value. And we haven't created this yet. We're going to create this, and then we'll do the on key up equals send message. And again, we're going to create this as well. Actually, we might as well fill out these messages while we're here, and then we'll go on to create the message state and stuff like that. So we'll add inside this div, we'll add some curly braces, messages.map. And then inside that, we'll have some brackets here, message index, and then the arrow, anonymous arrow function here. We'll create a new brackets here because we're going to return another component, some JSX. We'll do div key equals index and class name equals, and the class name is going to be a string here using the special syntax. So they're like little backtick quotes. On my keyboard, it's next to the Z key on my Mac OS keyboard. I'm sure it's on your keyboard somewhere. You need that because in JavaScript, that's how you create a kind of template string. So insert variables into a string, essentially. We'll type message and then $ open braces to insert the message.role equals user, and then question mark. That'll be user. Otherwise, just blank. So I'll explain what this does in a moment. We'll just type the rest of it out. So I'll close my div tag here, and then we need another div, or we need a closing div element here. We'll put message role equals user question mark. It'll be me, the sender, and then otherwise colon AI colon. Have a space there. And now we'll do message.content. Okay, so we'll type out the rest, and then I'll talk through what all of it does, just in case there's any of this that you didn't understand. I'll explain how it works. So inside the function, our app function, that's our component function, we need to add some state. So state, if you're familiar with React, is what keeps track of variables and data that impact the UI. So state is information that needs to be stored in a variable that can be shown for that particular component. So we'll do const message, set message equals use state, and we'll set it to just blank. And then const messages, set messages equals use state, and then this empty array. And and we'll do const set message equals e, and the arrow function here, if e.key equals enter, then set message and set messages, a new array messages, comma, content, colon, message, comma, role, colon, user. Okay, so what are we doing here then? So set message here should be send message, sorry, that's my mistake. So this is the method that's called, or function that's called to send a message. Okay, so let's talk through how this works. First of all, let's check in the browser if it actually does work. Okay, so if we type some things out here, you can see that it's adding new messages to the box, but it's not styled properly. So I think there's a typo somewhere in the code. So the issue is here, there should be a space. It's a very subtle issue, but basically the class name should be a space. So now you can see that it's styling the messages with the blue background. So it's just a simple chat interface. As you add more messages, it should scroll, but we should stay scrolled to the bottom of the screen. Okay, so let's see how this is working. So essentially, we define two pieces of state. So the message, which is used to store the message that's been typed in by the user. So that's the message that you type in here. As you type it, the way that React works is if you want to do what's called a controlled component, which means you keep track of the input that has been entered into that component, then you need to store it as state and you need to update it using this set message, the setter for the state update essentially. So this line 6 is used to track the message that the user's typed in. And if you look at the input box here, you see that it's just a standard input box. The set message is called on change. So every time there's a change to the contents, we call set message, which takes the value from e.target and calls the set message state setter here on line 6, this set message here. So essentially that updates the state of that message every time the user presses a key. Then on key up, so, or the value of this thing is set to the value of the state called message. So that's line 6. And then you have the on key up, which handles the enter key press. So I didn't have a send button. I just made it so it sends whenever you hit enter. So essentially every time the key is pressed, it runs the send message function, and the send message function checks here whether the key press is enter. So if the key is enter, then clear the message that was in the input, because usually in the chat, when you send a message, it clears the message that you typed. Clear that by calling set message with empty string, and then call set messages, which is the other state variable here, messages, which contains an array of all the messages sent to and from the chat, or it will at least. So right now I'm just having a hard-coded array. What we're going to be doing is we'll be getting this information from the API instead of hard coding it in a moment. But for now, just to demonstrate the UI, we have the messages state, set messages. So we call set messages on line 12. The way that React works, if you're not familiar, is when you are using state, you shouldn't ever do something called mutate the state, which means you shouldn't ever change the value of the state. So you wouldn't change messages by just pushing it straight to messages. You need to call set messages with the new value that you want to show. So that includes all of the existing messages with the content. So mutating the state would be doing this, calling messages.append or messages.push, I think is for adding new items, and then adding the item here. That would be called mutating this, because you're modifying the existing messages state variable. In React, you can't do that. You'll get errors and it won't work. So what you do instead is you call set messages to update the state value, and you passing the new value. In this case, our new value will include all of the existing messages in the current value. So it overwrites it, but in the logic, we're including all of the chat history. So it doesn't just update it to the latest message that was sent. We include all of the existing messages plus the new message that was added by the user in the structure that we're expecting here, content and role. And then what we do here is we have the kind of div wrappers that match with our CSS. And here in the messages, we go through all of the messages in the state and we map it to a component. So for every message, we render the lines 22 to 28. And essentially what that does is it has a div. Inside the div, we're creating a new class with the name message. And we have this logic here to say if the role is user, then add the user class in addition to the message class. Otherwise, don't. Otherwise, just leave it blank. So that's how we get the alternating color. So any message that's sent from the user will be styled as per the message.user. Any message that's sent otherwise, which will be the messages we get back from the AI, will just be styled with the gray color, the default gray. Okay, and now we just have the prefix that says either me or AI. So you would either say user or whatever you want to call your bot. You could just call it bot, but this just prefixes so we can see who the message was sent from. Okay, so we're almost there. Now that we've got the UI, let's go ahead and save the changes. So git add dot git commit -am added chat interface. Now we can move on to the next step, which is to basically connect up our front end with our back end. What we're going to do is we're going to do something called use effects to initiate some kind of polling. Now, this might not be best practice in React. In most applications, I possibly wouldn't do it this way, but just for the purpose of this demo, I think it's good to explain how this works for the kind of polling setup that we want. So essentially, use effect allows us to synchronize our component with an external system. So it's the way that we can sync up with our API to have changes show in the UI, and I'll show you how we set that up now. So what we're going to do is we'll leave the state here, but we're going to add a new state variable called session ID, because if you remember, the first step of sending messages to our backend is we need to create a session. So we'll do const session ID set session ID equals use state null. So by default, the session ID is null when they first render this component. And then what we'll do is we will add some logic to basically poll the session for messages and update the messages when we get new messages from the session. So we'll do that using use effect. And in here we pass in a function with the logic that we want. So if not session ID, then return. So if there's no session set, then do nothing. But if the session is set, then we want to do this. So const interval ID equals set interval, which sets up a recurring interval for the polling. Async calls an async function. And then we do const response equals await fetch. And this will fetch, again, we'll use the little backtick quotes here. So http://localhost:8000/API/chat/sessions. Chat/sessions, got to spell it right. /$ curly braces session ID. And then just end there with a / there, comma. We'll do method get, and then we will close this up here, and then we'll do const data equals await response.json and set messages data.messages. And then after the closing curly braces here, we'll do comma 1000. Okay, so after this line where we set the polling interval to 1000, we'll do return and then a function which calls clear interval ID. Okay, so now that we've typed this, we'll just do comma session ID here, which basically says use effect is initiated when this variable is modified. So when anytime the session ID state changes, it will call this use effect. What this is doing here essentially is if there's no session ID, then it does nothing. So when it first loads and there's no session ID, then it just returns and doesn't do anything. Otherwise, if there is a session ID, then it moves on to the lines 13 and below, which will call this set interval, which is a JavaScript built-in function that allows you to poll something on an interval basis. So run some code every, let's say, 1 second, like we're doing here. So we are setting an interval and we're passing in the asynchronous task here, or an asynchronous function that allows us to make the request to our API. So here we are setting const response equals await fetch. So we'll use the fetch, built-in fetch API, which is the API for making requests to a HTTP request to a backend. And we're hard coding a URL here. So in reality, you'd probably do this using some kind of configuration variable on the application to see where the backend is hosted. In our case, it's always hosted at localhost 8000, so that's fine. So what we're doing here is we are passing in the specific endpoint for getting the session. So every second this will run, it will call the fetch API to fetch the session by the ID specified here using HTTP GET, although you actually probably won't need this because I think HTTP GET is the default for fetch. And then after that's returned, we're going to call the JSON.response, which will pass or convert the string response into a JSON object. So that will give us the response from our serializer of the sessions endpoint. And then we're calling set messages with the data.messages, which will update the state of the messages to the messages that were returned from the session. Okay, so now that's done, we can move on to add a new function called post message. So we'll do that below this kind of use effect statement. We'll do const post message equals async session ID message, and then the arrow functions here. So we'll do await fetch, and then again the endpoint URL localhost 8000 /API/chat/sessions / and then the curly braces here, the session ID, which we will include in the URL. And then comma, we'll add the details of the fetch. So this time we want to do method post because we want to do a HTTP post for sending a message. And we'll do headers. We need to include the headers content type application JSON, and then comma, and then we'll comma off that, and then body, we'll do JSON.stringify message. Okay, so this is a function which calls, we'll make sure we close all the brackets here properly. I think I may have missed something here. So no, I didn't miss anything. So this looks good. Okay, so now we have a post message function, which is an asynchronous function that allows us to pass in a session ID and a message. And it calls the fetch API for making a request to the API/chat/sessions with a HTTP post. And the body of the post is a stringified, so a string version of the JSON, which includes a message key and a message value. So that's the message that we want to send to the user. We specify the headers content type application JSON to tell the backend that expect the content to be a JSON object. Okay, so now that's done, the last step is to modify the send message so that instead of just adding the message to the chat log, we're actually going to make a request to the API. So you can clear out everything within the key equals enter, and we'll type if not session ID, then const response equals await fetch HTTP ://localhost 8000 /API/chat/sessions. And then we actually need to add a sync here so that we can use the asynchronous functionality of JavaScript. And this is going to be method post, and we will close that off here, and then we'll do const data equals await response.json, set session ID data.id, and then post message data.id message. And then we'll do else post message session ID message. Okay, and then after that, we need to set message to blank just to clear it. So essentially, this updates the logic so that when we send a message, it checks if there's a session ID first on line 39. So if there's not a session ID, then we need to create a new session. So that would be the case if there's the first time the user loaded the page and they haven't sent anything yet. So if there's not a session ID, then we use fetch to call HTTP localhost 8000 API/chat/sessions and do a HTTP post. This makes a post request, which triggers a new session to be created and returns a response with the session ID. So then we get that response, we pass the JSON into an object that we can use in JavaScript, and we set the session ID to data.id. So it sets the state for session ID to session ID, which then, because of the session ID here, will trigger the use effect to run and start polling our session for updates. So every second it makes the request and checks for new messages. And then what happens is we post the message that a user just typed to the session. So because we had to create the session, we created the session first, and then we call post message with the session ID, and that sends the new message. Okay, you can see I'm pretty inconsistent here with the semicolons. Usually I have a tool that auto adds all of them, but I think they're kind of optional now in this version of JSX. Okay, so if the session does exist, then what we do is we just post the message to the existing session. So we only need to run the logic on line 40 to 48 if it's the first session. Otherwise, we just run line 50, which is the post message, which will add to the existing session. Regardless of what happens, every time the user hits enter, we clear the message input. That's why we have the set message here. Okay, so now, hopefully if there's no typos or errors in this code, it should work. We can actually open up the console here where we can track the history. So the way that I did that was Command Option I. If you're on Windows, it might be Control Option I. Or you can just right click anywhere and do Inspect, and it will take you to this, and then you go to the Network tab, and we'll filter by Fetch XHR, which will give us all of the API requests. Okay, so now let's test this by typing hello. Let's see. You can see that it's put our message here and it's output the message, and it's polling the backend for new messages. So every time we type something, we just type hello again just to annoy our unhelpful assistant. You can see that it's given us outputs here. So hello, oh hello there. What thrilling task can I assist you with today? And I said hello again, so it said, wow, deja vu, still here, so what's on your mind? And you can just keep going, so I wonder, I think it will probably go forever. That's the kind of beauty of these AI things, is you can just keep sending requests. Still greeting me, I see, what's the plan here? Are we going for a record? Yes. Well, in that case, welcome to the infinite loop. What's next? Goodbye. Let's ask it, what's the record so far? It says, I'm not exactly keeping score here, but I'd guess it's somewhere between boring and yawn-inducing. Want to spice it up? Sure. And yeah, we could keep going all day. So you can see how much fun chatbots are. Okay, so this is the chatbot. It appears to be working as expected. You could add more details to the system setup, which allows you to customize how the chatbot responds. You could add a lot more context to it, build upon the system prompt in order to make it really specific and add some unique value for your users. You can also do things like configure OpenAI to work with certain functions, which gives you functionality that is quite dynamic and allows the the chatbot to actually access external data. If you're interested in learning about that, then please comment it below and maybe we'll create some content about it in the future. There's other things like you of course would want to add authentication to this page if you were to push it to a live site, just because it's currently not authenticated. So anyone who can access this could make requests, which even though it's relatively cheap to make the requests from this model, you still don't want strangers using it and making requests on your API key. So you might want to add authentication, protect it in some way if you're deploying it, and so on. You might want to style the outputs to allow the chatbot to return with some kind of rich text response or something like that. Okay, so that's our working chatbot. Thank you so much for watching. I hope you found this video useful. If there's specific things that you'd like us to create content for in the future, then please leave them in the comments below. Or if you have any questions, please ask them in the comments below. And that is greatly appreciated. And I'll see you next time.